This video is on polymerization. So this is how polymers are formed. Polymers are large, usually in a chain, large molecules, like super large. So it's a whole bunch of small pieces put together. Think of like a big Lego structure. It comes from all the little pieces. The little pieces in a polymer are called a monomer. Mono meaning one, poly meaning many. So a whole bunch of small molecules come together in these long chains. Some are synthesized, meaning they're made in a lab. These are things you may have heard of, like nylon or Teflon. Some are naturally made, polysaccharides, proteins, nucleic acids. So there are two types of polymers, addition polymers, where different monomers come together, or condensation polymers, where they come together in a different way and water is a byproduct. We're going to focus on addition polymers. So addition polymers are when you have unsaturated monomer molecules, so alkenes. Unsaturated means you have a double or triple bond, so it's not just single bonds. And there's no byproduct, so there's no other thing that gets left behind. It's just these pieces coming together. So examples are things maybe you've heard of: polyethylene, polypropylene, polyvinyl chloride, also known as PVC, or polytetrafluoroethene, also known as Teflon. So what happens in these is the pi bond, like it says here, is part of a double bond. That part breaks. When that happens, so like you have, for example, carbon-carbon double bond, let's see here. When this breaks right here, so this is gone, you get this free radical where you have an electron on either side of the carbon. So what used to be in the bond is now over here, able to bond with something else. So this will keep continuing, and they'll keep attaching to other free radicals, or other molecules, I should say. When two free radicals form, that ends it. So an example of one is polyethylene, or polyethylene, it's sometimes called. This is when you have a whole bunch of ethene monomers. So N stands for just any number. So I'll come back to this uses in a second. This comes from when you have the monomer of ethene. So kind of like I was just drawing, you've got carbon, and I'm just going to draw my hydrogens up and down like this. All right, I'll draw them once. I'm not going to draw them every time. All right, and like I said before, right, this bond right here breaks. Okay, so this was the monomer, and those electrons go here. So the monomer is this ethene. The repeat unit is the part where it comes together in this group over and over and over again. So the repeat unit is C to C. You've still got your H's here. And they're going to bond on either side. And we draw this in brackets to show that this is what repeats over and over and over again. So basically you're just taking this piece and putting another one on it, and another one and another one, and number of times. Okay, so for example, you could have, go down a little bit. Okay, so you could have that carbon, carbon, right? Here's your H's. Okay, then you could have another one on here. And you could have another one on here. Right? You could have another one on here. So you can see what gets repeated, right, is this C to C part, right? It gets repeated over and over and over again. So like this one has, let's see, green, blue, purple, red, black. We've got 5 different repeat units. Okay. So that's polyethylene or polyethene. So another one would be polypropylene. So polypropylene means we start with propene. So our monomer is propene. So propene means it has 3 carbons. It has to have a double bond, right? And then, right, I had H's here before. Doesn't matter which one I choose, but one of these, instead of having just H, has a CH3 group. Okay, so this is propene, right? And I could draw it like this. okay? But I'm drawing it the way I did down here because the monomer, right, breaks at the double bond. So our repeat unit is the carbon, carbon. Notice I'm not going to draw a double bond. I'm going to draw that as a single bond because it breaks apart, and that's where it bonds. So my repeat unit is this in blue, okay? Because it breaks right here, right? Meaning this is going to bond and this, which is why I just drew this over here. All right, so another example, PVC, polyvinyl chloride. This is when we have vinyl chloride or chloroethane. This is, you've heard of PVC, right? Pipes, fittings, house siding, different kinds of things. Really thick, strong plastics. So the monomer is carbon double bond to carbon, hydrogen in all except chlorine, right? Chloroethene. We've got chloro right here with our ethene as the C double bond, the C. So our repeat unit is that double bond breaks. So we've got single, right, chlorine. And now we've got the bonds on either side of where that double bond used to be. All right. The last one is to talk about is Teflon, polytetrafluoroethene. So we've got, so think about what tetrafluoroethene means. It means that tetra means 4, fluoro means fluorine, and you've got ethene. So your monomer, right, would be ethene. And if it's 4 fluorines, right, that's fluorine where you had all the hydrogens before. Okay, so then your repeat unit is carbon single bond. Still have your, oops, goodness. You still have your single bonds with fluorine. And now it bonds on either side of that double bond. A number of times. All right, so those are monomers and repeat units for just some addition polymerization reactions.